Okay, folks, so let's go ahead and do two more of these. Just like A and C, we're going to see that B and D are very similar problems. One will be what I called a perfect u-substitution, while the other one will require some shifting of the constants. So again, in this case, I look up at the integrand for B, and I see the expression x to the fourth, and I see the derivative of that expression up to, and in this case, including the constant, but it doesn't have to include the constant. Okay. So in this case, we will let u equal x to the fourth, but that means that du would equal 4x cubed dx. So I look up ahead, and I see, okay, in place of the differential x, I've got differential x, great, and I've got an x cubed factor, I've also got a 4 factor. So in place of the product of these three factors, I'm just going to simply replace that with a differential u. So now we're ready to do that substitution, and we find that this integral is equal to the integral of, and then in place of the x to the fourth, I'm going to replace it with a u. And now in place of this triple product, or these three factors, we've got 4x cubed differential x. In place of their product, I'm just going to simply put differential u. So this is now a little bit easier on the eyes. I can think of taking the antiderivative of the sine of u much easier than I can think of taking the antiderivative of this expression through this change of variables. So let's go ahead and do so. What is the antiderivative of the sine of u? Well, it's the minus cosine. Oops, that's not a letter. It's minus the cosine of u plus c. Of course, u wasn't the variable we were supposed to be working with. We're supposed to be working with x, so now we have to, the phrase is back substitute what u was holding the place of. So we get minus the cosine of x to the fourth plus c. All right, now let's look at letter D. So just like before, letter D is not going to be a perfect substitution. Nonetheless, we see the expression x to the fourth, and we see its derivative up to, but in this case, not including the constant. So let's go ahead and just like we did in the last problem, let's let u equal x to the fourth. That would tell us that du equals 4x cubed dx. But in this case, I'm looking up and I see, okay, I'll be able to replace the differential x and the x cubed. There's the differential x and the x cubed with du, but I've got this extra factor of 4, and I don't have a 4 there to make this substitution perfect. So let's try this trick. And again, everyone does these a little bit differently, but let's try this trick of dividing over this factor of 4. So that gives me 1/4 differential u may be replaced with the expression x cubed differential x. So now we're actually ready to rewrite this problem using a u substitution. Now notice I'm not going to be replacing the 7 with anything, so we still have 7. And then in place of the sine of x to the fourth, well, in place of that x to the fourth there, I'm going to use the substitution u. And then in place of this x cubed times differential x, in place of their product, I'm going to place 1/4 differential u. So that 1/4 differential u is going in to replace those two factors. We can now clean this up substantially. We get 7/4 times the integral of the sine of u du, and as far as the integration step goes, this isn't too bad. Just like before, the antiderivative of the sine of u is minus cosine u, so we get minus 7/4 times the cosine of u plus c, with a final step of replacing the variable u with the variable it was taking the place of. We're back substituting, and so we end up with minus 7/4 times the cosine of x to the fourth plus c. Again, I highly, highly encourage you, in fact, let's just do this. I'm going to check this in your notes. Did you check this by taking the derivative of this expression and show that you get this? So take the derivative of minus 7/4 cosine of x to the fourth plus c, and I want you to do the appropriate chain rule and see that you end up with the same integrand that this problem started with. All right, so that's the intro to the u substitution. Go ahead and keep working through. I think at this point you should be ready to work through E and F and G, and go ahead and work through them. I will help you with a couple of those, but spend some time working on them. All right.